Hey there, Python trainer Reuven Lerner here. And today I want to talk about dtypes in pandas. Specifically, I want to talk about something that came up in one of my corporate pandas training classes earlier this week that forced me to look into things a little and investigate both what happens now in pandas and what's happening in the future as we move forward with the library. So let's start with NumPy. And I want to start with NumPy because I have long described pandas as sort of a wrapper around NumPy. I sometimes say that NumPy is the manual transmission and Pandas is the automatic transmission. So if I say import NumPy as NP, and then I say here A equals NP array of, we'll say here 10, 20, 30, 40, 50. Okay, so far so good. And I can ask, what is the dtype of this? And dtype means what kind of data is being stored in this array. And it says it's an int64, meaning each and every one of these integers takes 64 bits. And it's an integer, right? So what if I say a of 2 equals 1, 2, 3, 4, 5? Well, that's fine. We're just going to switch it around to be 1, 2, 3, 4, 5. So far, so good. What if I say a of 2 equals 1, 2, period, 3, 4, 5, right? That's now a floating point value. And basically, NumPy chops it off and says, well, the dtype is an integer, thus we are going to keep only the integer part. It's not rounded, it is just cut right off. And we know this because if I say a of 2 equals hello, it's going to give me an error. And the error is going to be, I can't turn hello into a base 10 integer. Okay, great. Now let's move to pandas. If I say import pandas as pd, and now I say, I'm going to also say from pandas import series and data frame, because like that just makes life easier for me. I'm so used to doing it. So now I'm going to say s equals a series of 10, 20, 30, 40, 50. And behind the scenes, there is a NumPy array here. Right now, if I check, we'll see there's a dtype of int64. If I say s.dtype, we're going to get dtype of int64. It's exactly the same dtype as we have before, because behind the scenes, there's a NumPy array. How do I know this? I can ask s.values. Well, look at that. It's a NumPy array, type of s values. If you don't believe me, NumPy array. So what if I now say s, and I always like to use .lock, of 2 equals, and we'll say here 1, 2, 3, 4, 5. And that works just fine, as before. What if I say s.lock of 2 equals 1, 2, 3, 4, 5? Wait a second. This is wildly different behavior. And we see it's wildly different behavior because, well, instead of chopping off our integer, chopping off the float's fractional part and leaving us with an integer, it turned the dtype of the entire series into a float 64. Well, wait, what if I say s.lock of 2 equals hello? No errors. And now the dtype is object, meaning each and every one of these things is a separate Python object, right? Or an internal object. It doesn't really matter. Basically, now I can throw anything I want in there. And this is kind of weird, right? Especially if you're used to NumPy. So someone in one of my classes this week said, is there any way for us to stop that? And I had to really investigate. And my initial discovery was no, you can't really stop that. And why can't you stop it? You can't stop because if I say here s equals a series of 10, 20, 30, 40, 50, okay, and then I say s.lock of 2 equals pd.NaN. I want to put in the NaN value. Well, NaN is a float. Oh, wait, sorry. Not pd.NaN. It would be np.NaN, right? I'm getting ahead of myself here. If we want to have NaN in that column, NaN is a float. Thus, we must turn that column into a float column. Basically, if we couldn't do this, if we were to assign it and it didn't change its dtype, we wouldn't be able to put it in NaN. So that's kind of annoying, right? The only way that we can make a nullable type, well, is to force everything to be a float. So this means if I have s equals a series of, A, B, C, D, E, F, G, H, I, and I do a split here. So now, right, my dtype is object. And if I say s.lock of 1 equals np.NaN, well, that's fine. They're all objects. This is a float object. This is a string object. This is a string object. This is nuts. But this is the way it has been in pandas for years and years and years. NaN is a float. I can even prove it to you, right? If I say here, what's the type of np.NaN? It is a float. And so if we want to use NaN, we must either turn the dtype into float if we can, like if it's an integer, or if we can't turn it into a float because it's like strings, well, we'll just have another object around. So what can we do about this? And at first I thought, no, there's nothing we can do. But then I thought about it a little more, and I remember that pandas is moving in the direction of nullable types, meaning that there will be an integer type with its own null value, or a value that does not force it to be a float. Well, what do you mean? How can that be? So it turns out that when I say S equals a series of 10, 20, 30, 40, 50, the default D type is indeed still going to be the NumPy type, but I can change that. I can use some of these extension types that are now available in Pandas. So for example, I could say D type equals pd dot, and then I'm going to say here int 64 D type. That's 16. Doesn't really matter, but I'll make it 64. And look at that. The D type is now int64. Notice, by the way, you say int64 D type and you invoke it. You want to get back an instance of it. If you pass the class like this, it's going to be object. Don't do that. That's not what we want. So I pass this here. It's int64. Okay, so what? Well, I can still say s sum and all that other stuff. And s.dtype is, of course, going to be int64 D type. But what if I now say s-lock2 equals, well, what if I say np.NaN? What's going to happen then? Wait, it's not NaN. It's this other thing. It's NA. And the D type has stayed in 64. What we have here is a nullable integer type. And that's only possible because we now have this thing called pd.NA. Oh, well, it's not pd.NA. Keep getting that wrong. And you can see it looks like it's kind of funny. And so this pd.NA can actually work with all types. We don't need to force the D type to be something else. We don't need to force it to be float. And we don't need to force it to be anything else. That is fantastic. Because now, if I say s.lock of 3 equals 1, 2, 3, 4, 5, what's going to happen? It blows up. It doesn't let me do it. Why not? If we scroll down all the way here, it says invalid value 1, 2, 3, 4, 5 for D type in 64. So we're really benefiting in two different ways here. First of all, we are guaranteed to have integers and only integers. And that means that we're not going to have the D type changed. Moreover, NaN, or now we can say NA, will work with all these different types. It won't force them to be a different D type. That is fantastic. So what if I now, let's do this. I'm going to say here, df equals a data frame. I'm going to create it as a dictive list. So I'm going to say A is, like, we'll say 10, 20, 30. That's going to be my first column. And B is going to be 1, 2, 3, 4, 5, 6, well, that's what matters, 5, 6, 7, 8, 9, 0, 1, 2. And then C is going to be hello out there, split. So if I now do this, I say, show me df. So we have a column of ints, a column of floats, and a column of strings. If I say df.dtype, we are going to see that we have int64, float64 object. These are our NumPy types. And if I want to set anything column A to be NaN, it's going to do the old thing. But I can say df.convert dtypes. And this method returns what looks like exactly the same data frame, right? But if I now say df equals convert dtypes, and I say df, so far so good. And now I say df.dtypes, oh ho ho, totally different. The D type of A is now int64. That's that nullable version, meaning that I can put an NA in there and it won't turn into a float. I have B, which is float64, and that's actually going to work pretty much the same way. And I have C, which is a string D type. This is not something we've seen before. If I say df lock of 2 comma C equals pd.NA, you know what's going to happen? I'm going to see NA there, and df.dtypes is going to remain string Python because this is a nullable string type. This is a big deal, folks. This is a big deal because it guarantees that our types will remain what we wanted them to be. And it's a big deal because now we have nullable types, and we don't need to move everything around to be floats. By the way, this explains why if I say df.drop.NA, it's not NaN, it's NA. Now, it works with NaN also, but NA is like the modern cool kids way to do it. If I say df.fill.NA, well, then I'd say, like, I don't know, 10. Well, it's not going to like that because you can't put 10 in there because it ain't a string, right? If we go down here, cannot set non-string value into a string array. But if I say df fill NA to be, hello, let's do string 10. And now we're totally fine and all is good. Now, these are still new. These are still labeled somewhat experimental, but you can see why they have such promise. And this is part of that whole process now of Pandas kind of pulling away from NumPy and doing its own thing. So I hope this helps you to understand nullable types, how we can enforce types on our pandas data structures, what's going on in the pandas world, and what this whole NA versus NaN thing is. I hope this was useful and interesting for you. More is coming soon about Python pandas. Please comment if you have any questions. Subscribe to get more stuff about Python pandas, and I will see you here really soon again.